Hey guys. So I was asked to do like a review of integrated math 2 unit 9. So that's what I'm going to be doing here today. Well, 9-1 at least. So I have a couple example problems. I'm probably going to write more. And then after that I'm going to do 9-2. But first of all, I'm posting this one. Focus camera. Focus camera. Okay. Whoa. Okay. Okay. So let's have our first problem here. And here's actually one of the rules that we have in when adding or subtracting square roots. If you have two terms with the same root, then you just add or subtract the outside numbers and this root 2 will stay here. So for example, we have 2 root 2 minus 7 root 2 equals negative 5 root 2. Because we have 2 root 2's here, so we can ignore them, do 2 minus 7, which is negative 5, and then it's just negative 5 times root 2, because that's the same term here and here. Now, sometimes your roots are not going to be the same. Right here, we have two terms with root 6, and you can combine those terms. And since we have two of the same term, ignore the terms. We have 2 minus 6, which is negative 4. And then we have root 6, so we add the root back. And then what do we do with this 3 root 3? Well, because it isn't, it's not the same root, so we just keep it as is. And I'll do another example problem because I feel like I should probably double down on it. We have 2 root 5 plus 7 root 5 minus 2 root 10. If you want to pause the video and try to solve this, I'll give you guys a couple seconds to pause and go ahead and do it. And if you didn't pause, you suck, unless you already know this. But your answer should be 9 root 5 minus 2 root 10. Because you have 2 plus 7 is 9, and so you get 9, and then add the root 5 back, 9 root 5, minus 2 root 10, because this isn't the same thing as some of the other ones. Anyways, now we're going to move on to something a bit more complicated. Root 48 minus root 75. So I do have the answer right here because this is one of the other example problems. So I know if I'm going to do something wrong. Unlike last time, I tried doing one of these. So we have root 48, and make sure you have space on your paper to write this, because if you don't, you're kind of screwed. Anyways, you have root 48 and root 75. And when you are factoring, you are sort of boiling a number down to its base parts. I will demonstrate that here with root 24. Okay, so it's not these, but this is my example. So to factor, you find what two numbers multiply to equal 24. In this case, I want to use 4 times 6. And these are two numbers that multiply to equal 24. Now we have to find two numbers multiplied by each other to equal 4. And you use 2 and 2. What two numbers multiply to equal 6? 3 and 2. Now, for simplifying, it's a bit more complicated, but specifically for square roots, all you need to do is find if you have 2 of a number. Any number. If you have 2 of a number on this, you can take that number out of the radical. Right here, you see that we have 2 2's. So our final term has 2 on the outside, right? But what about the 3 and the 2? There isn't another 3 and there isn't another 2 because we've already taken these out, so we can cross them out. We have the 3 and the 2. Well, because there aren't any more 3s or any more 2s, you leave that in. 3 times 2 is 6. So we take the 6, and it's just root 6. So root 24 is just 2 root 6. And this is how you do it. You have 2 2's, so you take them both out of the radical, and you just get 2. And then you have a 3 and a 2 that you can't do anything with, and these 2 multiply to 6, and the 6 stays inside the radical. Now let's apply this back over here. So over here, we can do 4 and 12. This is 2 and 2. For 75, I would want you to do that. On your own, if you can. If not, that's fine. We're all learning here. But we have 4, 2 times 2, and then 12 can be 3 and 4, and this is 2 and 2. Now, what do you do when you have 2 pairs of 2's? So, let's take our first pair of 2, and let's say root 48. Let's put down here root 48. Oh gosh, okay, equals blank. And we have a 2. This is our first 2. But wait, we have another set of 2's right here. So what do we do with those? We also take that out of the radical, and we have another 2. And then that leaves us with a 3. This 3 right here. Because it doesn't have a partner. It's a solo 3. So that stays in the radical. And because we have 2 pairs of 2's, these 2 pairs of 2's multiply to 4. And you get 4 root 3. Now, the easier way to do this is to just look over here and say that you have 2 4's. You can do that. That's easier. But sometimes if you're not doing things in, I guess, the most optimal way, like sometimes you might have a super huge number, like the root of like 1,254 or something crazy like that, and you just start taking out 2's, and then you take out more 2's, like right here. I think this would be 627, which you can't factor out a 2 from, so scratch that. That doesn't work. This example doesn't work. I'll try another one. Like 1,000. Let's say, theoretically, you didn't know about 502 or 110, and you just started going 2, 500, 2, 250, 2, 125. You have 3 2's. Let's say, theoretically, you had 4. You probably wouldn't have the actual number 4. So you wouldn't just be able to say, oh, I have 2 4's, take out the 4. Sometimes you have to count the amount of smaller numbers you have, in this case 2's, and you have to take out 2 and then take out another 2. 2 times 2 is 4, and then 4 root 3. If that's too confusing, don't worry about it. Anyways, so now we have 75. 75, you can do 3 and 25. And then 25 is 5 and 5. You have 2 5's. So you take the 5 out, but you still have a 3 left over. So it's 5 root 3, right? And then it's root 48 minus root 75. And so what is root 48? Well, we know that's 4 root 3. What is 75? Root 75. That's 5 root 3. So it's 4 root 3 minus 5 root 3. Go ahead and solve this. The answer is negative root 3. And that's basically it. But what happens if you're multiplying? Focus, camera. Focus. Okay. What happens if you have 10 times the square root of 6p cubed times 3 root 18p. And I think I just said this wrong. It should be 10 root 6p cubed times 3 root 18p. Write that down over here. So for this right here, you can simplify parts of these terms. So let's take the term 10 times the square root of 6p cubed. And let's take, how should I do this? There's actually a couple ways you could do this. Let's do this way. 10 times root 6 times root p to the cubed. So let's take our p cubed. As for this root 6, that root 6, spoiler alert, that's going to stay as a root 6. Because as we've seen over here, where's my examples at? I don't have any. You see? Oh, I do right here. You see the 6 only factors a 3 and a 2, and it stays inside the radical. So that's probably going to stay inside the radical for the time being. However, this p cubed can be p squared times p. And this p squared is p and p. So we have two p's, and those two p's go out of the radical. So now we have 10p root 6p. Do you see how we got that? We have p cubed, which is p squared times p, and p squared is p times p. We have two p's, therefore it leaves the radical and joins the 10 outside of it. And so this is our first term. Now let's take 3 root 18p. 3 root 18p, and I actually need to look at this just in case I'm doing this wrong. Okay, I'm doing it right. Okay. 3 root 18p. We can simplify 18 as 2 and 9. 3 and 6 also works. But I'm going to do 2 and 9. For 9, we have 3 and 3. This 2 is alone, but these 3's are a pair. So these 3's go outside of the radical, and now we have 3 parentheses 3 root 18p. And since there's already like a number right here, 3, and we're taking 3 out of the radical, it's just 3 times 3. Because we moved this pair of 3's to the outside, but there was already a 3 there. So now it's just 3 times 3, which is 9, and that is also not 18p. That should be 2p. But we have 9 root 2p. And this is our next term. So we have 10p root 6p and 9 root 2p. Now, the next thing you do is I need to look at my notes to make sure I'm not going to mess you guys up. Okay. So, now we sort of we multiply everything together. How do we do that? Good question. So we have, where should I write this? Okay. 10p times root 6p and then 9 root 2p. So now with this we have, I believe we should have a p squared. There should be no p squared. Okay, hold on. I see what happened. Okay. So we have 10p times 9. This is 90p. But now we have root 6p times root 2p. When these are both square roots, or okay, so this is one of the rules we have. If we have root a times root b, a and b are our variables. This is equivalent to root a times b. Let's pretend that's a b. let's not. A times b. Root a times root b is equal to root a times b. This is a rule that we learned in this unit. So knowing that, let's apply that back over here. We have root 6p times root 2p, which we know by this rule that should equal the root of 6p times 2p. And if we multiply, we get root 12p squared. And now we have two terms, 90p and root 12p squared. Now remember how we had a p cubed over here and we were able to take out 1p because we had a p squared? Same thing applies over here. When we factor out root 12 and root p squared, because remember, if root a times root b is root a times b, then the opposite is true. Root a times b is equal to root a times root b. So we can split root 12p squared to root 12 and root p squared. Root p squared is just p and p. So we have a p taken out. And now we have 9, that is not a 9. And then we have 90p from over here, which is just 10p times 9. 90p times p times, and let's take 12. We have 2 and 6. 6 simplifies to 2 and 3. We see here that we have two 2's, so we take that out. And then we multiply this entire thing by 2. And then, because we have two p's over here, let's come back over here. We have root p squared. That's just p times p. We have no more terms, so there's no more root. Like that's just not a thing anymore. Now we just have p. However, right here, we have taken two 2's out, but we still have a 3. So this is still, at the end, we're still going to have a root 3. So we have a root 3, and now we have to multiply this. Doing some quick math in your head, that would tell you that this is 180p squared times root 3. And there should be your answer to this seemingly hard question. It's really not that bad. This is your answer. If you need, whoa, let's not look at that. If you need any other help, I am more than willing to explain more. If you have like a question, post it in the comments because I'm not showing my face, so YouTube's not going to block this. But yeah, and that is my quick review on Integrated Math 2 9-1.